Hi everyone, welcome back. Today we'll be looking at 6.G.A.1. Find the area of right triangles, other triangles, special quadrilaterals, and polygons by composing into rectangles or decomposing into triangles and other shapes. Apply these techniques in the context of solving real-world and mathematical problems. So let's start calculating the area of a trapezoid. Area is the amount of space inside the boundary of a flat two-dimensional object. Area is measured in squared units. A trapezoid, also known as a trapezium, is a flat closed shape having four straight sides with one pair of parallel sides. The sides that are parallel are called bases. The other sides are legs. So here we have these two sides that would be parallel to each other. And in this image, we would have this side parallel to that. And then the other portions over here and over here would be called our legs. So here's our first example. This trapezoid could be broken down into two shapes. We could draw a line along here and split it into a triangle and a rectangle. But for our purposes, we're going to work with it as a trapezoid, and we're going to be using the formula area equals B1 plus B2 divided by 2, and then we're going to multiply it by the height, which is the perpendicular height to the base. So for those who might need to see how I would split this, I would cut it right down the side and form a triangle and a rectangle. As such, I would fill in my dimensions, calculate the area of my triangle, the area of my rectangle, and then add those two numbers together. But that will only work if I have a right trapezoid. If you notice that over here, this leg is forming a right angle with the base, so that there would represent the height of this trapezoid. Right, so let's go ahead and clear that off, and then we're going to calculate the area using our trapezoid formula. So we're going to label the top part here as B1 and down here as B2. So those are our bases because these are the sides that are parallel to each other. And then over here, 15 is our leg, but it's also going to be our height because it's perpendicular to the base. And 17 would be the other leg. So the area is equal to 11 plus 19 divided by 2 times the height of 15. 11 plus 19 is 30 divided by 2, and then we're going to multiply that by 15. So that gives us 15 times 15. 15 times 15 is equal to 225. And our unit is centimeters squared, so the area of this trapezoid is 225 centimeters squared. Our next example, we're going to label our B1 and our B2. And then we're going to plug this into the formula. So A is equal to B1 plus B2 divided by 2 times the height, which is the height that's perpendicular to the base, and that's 3 in this example. 2 plus 6 is 8 divided by 2 times 3. So that's 4 times 3. So the area of this trapezoid is 12 millimeters squared. Now this example, we're working with some decimals. So we're going to do the same thing. B1, B2. Now, what if I put B2 on the bottom and B1 on the top? That's fine because I'm adding and we know that addition is commutative. So A is equal to B1, which is 0.3, plus B2, which is 0.8, divided by 2, times our height, which is 0.6. So 0.3 plus 0.8 is going to be, so remember when you're working with addition, you're stacking your decimals. 8 plus 3 is 11. I bring down my decimal, so it's really 1.1. We're dividing that by 2, and then we're going to multiply it by 0.6. Now when I'm dividing decimals, so I have 1.1 divided by 2. 2 cannot go into 1, so that's a 0. I'm going to put my decimal point up in my quotient. 2 can go into 11 5 times. 5 times 2 is 10. That leaves us with a remainder of 1. We add a 0. So 1.1 divided by 2 is 0.55. So here we have 0.55 times 0.6, which is our height. So now we're going to go ahead and multiply those two together. To multiply, we're going to pretend like the decimal is not there, and then we're going to count the spaces at the end. So 55 times 6, 6 times 5 is 30, 6 times 5 is 30, plus 3 is 33. Now here we had 1, 2, 3 spaces, so we're moving 1, 2, 3 in our answer. So therefore the area is 0.33 miles squared. So another approach I can take to calculating the area of my trapezoid is to take two of the same trapezoids and put them together and convert it into a parallelogram, and then use my formula for calculating the area of a parallelogram, which is a equals base times height, to calculate it. So here in the second image, we have the first trapezoid and the second trapezoid. And if you notice that we had to turn this one upside down so that it would fit in nicely here. If we join those together, it's going to look like this third image. Now, if you notice that the top portion is now my base 1 plus my base 2. And then my height would still be the same. And if you think about the original formula, right, base 1 plus base 2 is exactly what we have there. And then when we find this, though, we would have to divide this area by 2 to calculate the area of the trapezoid. Okay, so let's go ahead and do that. So with this now, I'm given the dimensions of 8, and then my height, which is perpendicular to the base, is 7. So the area of the parallelogram A equals base times height, where the base is 8 and the height is 7. The area of the parallelogram is 56 meters squared. But here we know that we used two trapezoids to create the area of the parallelogram. So we're going to have to now divide that by 2. So the trapezoid would be equal to 56 divided by 2, and that would give us 28. So 28 miles squared would be the area of this trapezoid. Let's look at another example because I know that might have been confusing. And if this feels confusing, then disregard it and just stick to using the formula b1 plus b2 divided by 2 times height. This is if you're looking for a different way of solving the same problem that connects you with another shape that you've already learned about, which is the parallelogram. Okay, here we go. So we have the trapezoid here, and now we're going to put the two trapezoids together to create the parallelogram. Now, when I combine these two, I have 18 plus 7, which is now going to make that new dimension 25. And the same thing is going to happen here on the bottom. Now, my height is still going to be 20. So if I constructed this as a parallelogram, I would find that I have 25 here, and then I have this internal height of 20. And we know if this, whatever this measurement is, that measurement is, and that one would correspond with that one. So now let's go ahead and calculate this. So the parallelogram is A equals base times height, where my base is 25 and my height is 20. (25 times 20) is 500 inches squared. So that's for the parallelogram. Now, because we use two trapezoids to make the parallelogram, we have to now divide that area by 2. So the trapezoid, the area is equal to 500 divided by 2, which would give us 250 inches squared. Now let's prove that this is correct by using the formula for the trapezoid. So A is equal to B1 plus B2 divided by 2 multiplied by the height. So we can say base 1 is 18, base 2 is 7. So here I have 18 plus 7 divided by 2 times h. 18 plus 7 is 25. Divide that by 2 times 20. 25 divided by 2 is 12.5. And we're going to multiply that by 20. And the product of 12.5 and 20 is 250 inches squared. So here we found that our answers are exactly the same. Okay, again, if this felt a little confusing, then completely disregard this method and just focus on using the formula B1 plus B2 times H. And I want you to think about, a lot of these formulas are so interconnected. B1 plus B2 divided by 2, what does that sound like? What does that remind you of? If you said the triangle formula, then you're right? Base times height divided by 2. And here we have, again, something that we're dividing by 2. So make the connections between the different formula. It really helps with you memorizing them. Thank you for watching and have a great day.